Let's take a look at another example. Find the 6 trig function values of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0 and a constraint that my x values are always going to be greater or equal to 0. So we have to do 4 things here. Number 1, graph the function. 2, select the point on the terminal side. 3, find the value of r. And 4, determine the 6 trig functions. So let's start by graphing the function. The easiest way to do that is to take the equation, which is x plus 2y equals to 0, and actually solve that for y. That will put us in slope-intercept form, which will make it easier for us to graph. So x plus 2y is equal to 0. 2y is equal to a negative x, and therefore y is equal to a negative 1/2 x. Let's make a graph of the slope-intercept form, which is y equals a negative 1/2 x. I know that my y-intercept is 0, 0, since I have no constant at the end on the right side. So I'll just put a point at my origin, 0, 0, and I know my slope is a negative 1/2. So in this situation, I'm going to go down a negative 1, and then I'm going to go over to 2. That will give me my terminal side of my angle, and that gives me a rotation all the way counterclockwise. From there, we have to select a point on the terminal side. I'm just going to pick the one that's already given to us, and that location is actually going to be 2, negative 1. Now what we want to do is make a right triangle out of that situation. I'm going to change colors to help us out here a little bit. So I want to draw a right triangle from our initial side. That gives us our x value of 2 to our point on the terminal side of our angle, and that red line there will represent y equals a negative 1. Now, the next step is to find r. That's the distance from the origin to the point I selected on my terminal side. From there, as we've done in the last 2 problems, is to use the Pythagorean theorem. So r squared is equal to x squared plus y squared. R squared is equal to x squared, which is 2 squared, which is 4, plus y squared, which is a negative 1 squared, so that would be 1. Simplifying, r squared is equal to 5. The square root of 5 is going to give us r equal to the square root of 5. Now we have a diagram that shows a cleaner version of what we just did. Remember that our initial side has an x value of 2, and the vertical line to the point on our terminal side has a y value of a negative 1. And this represents our 3 values we need to use to find our trig ratios. We're going to find them the same way we did in the previous 2 problems. So let's start out by finding sine of theta. Sine of theta we know is going to be y over r, and in this situation we're going to get a negative 1 over the square root of 5. You need to recall that we're not allowed to have a radical in the denominator of a fraction, so I need to rationalize. I'm going to multiply the top and bottom by that denominator. When I simplify, that's going to give me a negative square root of 5 over 5. Continuing, cosine theta. That will give us x over r. That'll give us 2 over the square root of 5. Again, I end up with a radical in the denominator. I need to rationalize again. That gives me 2 square roots of 5 over 5. And then tangent theta, which is going to give me y over x, which is a negative 1 over 2. Let's find the reciprocal functions. First, cosecant theta, which I will use the original ratio, which is a -1 over the square root of 5. Find the reciprocal, which would be the square root of 5 over a -1, but that simplifies to the negative square root of 5. Next would be secant theta. Again, the original would be 2 over the square root of 5, so I'll just use the square root of 5 over 2. And then cotangent theta, which would be the reciprocal of tangent, which is a -2. Let's look at another example. Find the values of the 6 trig functions for an angle of 270 degrees. Well, the easiest thing to do is actually to graph the function to see what this thing looks like. Even though we're not given a function, we are given an angle measure. So we can actually represent that on a graph. Let me change some colors here and we'll take a look at it. Let's draw the initial side of our angle. It's in standard position, so we'll draw it on the positive x, and then we'll just go counterclockwise, 90, 180, 270 degrees. So my terminal side is going to fall on my y-axis. We need to select a point. We can select any point that's on my y-axis. Therefore, I do know that my x value is going to be 0, but I can select any point for y. The easiest one is going to be -1. So let's choose our point to be 0, -1. Just like in our previous examples, we have to identify our 3 values we need to find, which are x, in this situation it's 0, y, here it is a -1, I need to find r. So I'm going to do that by the Pythagorean theorem. R squared equals x squared plus y squared. Substituting, r squared is going to equal x squared, which is 0, y squared, which is a -1 squared, which is 1. R squared is going to equal 1, therefore the square root of that will be r equal to 1. Now I have my 3 values. Let's continue and find our trig functions. Sine of theta, which will be y over r, which is a -1 over 1, simplifying a -1. Cosine of theta, which is x over r, which is 0. And tangent of theta, which is y over x. Since my denominator is 0, tangent at 270 degrees is undefined. Reciprocal functions, cosecant of theta is going to be 1 over a -1, which is a -1. Secant theta will give us 1 over 0. So secant at 270 degrees is undefined. And cotangent theta will be x over y, which is 0 over a -1, which is 0. With this information, tangent theta and secant theta are undefined at 270 degrees. Well, then we have 2 situations we need to take a look at where functions are undefined. One, if the terminal side of an angle, quadrant angle, lies along the y-axis, which is in the previous example, then the tangent and secant functions are undefined. We already calculated that. We don't need to calculate the other one. We can just take a look at it and know it, which is if it lies along the x-axis, then the cotangent and cosecant functions are undefined for those values. Here's a table of the functions that help us out on quadrant angles. So we have the sine theta, cosine theta, tangent theta, cotangent, secant, and cosecant, all showing our quadrant angles. And they give us the values for those. I will make a PDF of this and I will place it on our group resource page so you can use this as a reference. This is our assignment. If you have any questions, please refer to the discussion board.